Yes, can you see that screen now?
Yes, sir.
Okay. So, student, good evening to all. And now today we will talk about the first topic, which is the introduction to nanoscience and nanotechnology. As we know, the BK Birla College is having the Nanotechnology Research Center since it is 2005 onwards. Professor Sharan from IIT Bombay, he has started this research center at BK Birla College, and that our credit goes to Dr. Naresh Chandra, who is our director of BK Birla College, Kalyan. He invited Professor Sharan from IIT Bombay, and he has started Nanotech Research Lab in Birla College. See, I was the first student of the Professor Sharan, and many students from our college has completed the PhD under the guidance of Sharan. So Professor Sharan is known in India as a father of carbon nano, and he was a very senior, experienced scientist, and he was there in our college to guide the PhD student in nanotechnology. So we will begin this topic by just looking at what is nano, what are nanomaterials, terms involved in nano, and many other things. So we'll go one by one in the slide. Um, yes. So nanotechnology, this nano is nothing but this is a Greek word which is taken, which is main is very small. It is called a dwarf. Dwarf means very, very small. So nano is nothing but we can say it is 1 billionth. Okay, that is the something is divided into a million bits, then even it be divided into 1,000 smaller bits. Technology means building the things, and nanotechnology means the nanomaterial used to building the things. Okay, or the building the things from very tiny parts. That is we called as nano. So as I says, there is a Greek means nano is a dwarf, and that is the very, very small. So nanotechnology is the engineering of the functional system at scale. So it is also be called as the atomic technology, molecular technology, that is macromolecules. We can bring this all together and form convert into any devices, and that is we called as the technology. So again, we can understand sometimes it is asked what is nano. So we can talk about nano means the 1 billionth, and that is nothing but 1 nanometer is nothing but it is 10 raised to power minus 9 meter. Okay, so that is 1 nanometer. So the nano scale involves the range from 1 to 100 nanometer, because now see many people started fabricating the materials. That is sometimes they say it's 200 nanometer the diameter, or 500 nanometer length, or whatever so on. So how these materials are, which materials they show the smart properties at which dimension, and that scientists found that either any material having one of the dimension is in the range of 1 to 100 nanometer is called as nanomaterial. Now you will say ki why the materials having any one dimension like length, diameter, pore size, pore volume, or many other things you can see that is one dimension. And if it is go more than 100 nanometers, so what happens? Their properties change. So if you called a smart material, that is nanomaterial, so its dimension must be in the range of 1 nanometer to 100 nanometer. So that is the definition, standard definition nowadays. It is available for this nanoscience. So if anybody can ask you what is the nanomaterial, so you can say the any material which is having the dimension any one dimension in the range of 1 to 100 nanometer is called as nanomaterials. And what is nano? Nano is nothing but 1 nanometer is equals to 10 to the power minus 9 meter. So these are the few definitions we must understand from the nano. How small is nano? Can we imagine how it is small? So you see the a piece of a paper of any newspaper, you can say it is, you can see the how thick is. So if you go for the nano size, you can talk about 1 lakh nanometer thick. Okay. Then you can go for an human hair. Our human hair is 80,000 nanometer in thick. Our DNA, it is 2.5 nanometer diameter. है ना? So DNA is the real nanomaterial, but not our human hair. Why? Because the human hair diameter is 80,000 nanometer in thick. So you can take the a gold atom, okay, a single gold atom. Its diameter is zero point 0.3 nanometer. So we can say it is the nanomaterial. So you can just imagine how this nano is, their size is compared to the other one. As you know, in the periodic table, we have seen the 118 elements are there in the periodic table and they are placed in the groups and the periods. Okay, so as we move down the group, you know, their sizes increases. And if you move from left to right, again, their size decreases. So it means the atoms which is present in the periodic table, always their sizes in the angstrom or these nanomaterials. So all elements in the periodic table, if it is a single atoms, and then they can say. So what happens and how these nanomaterials are generally formed, how we can see. Here is one slide is shown, and that slide shows that if you take that nickel atom, and as nickel atom, single atom, if you place it here, and its surface energy, you can see is very high, because smaller the size, having higher surface energy. But if you take that nickel atoms of 2 to 30 atoms together, and that it converted into a nickel cluster, and you can see the surface energy decreases. And then again, the stability is also increase. But the nickel single atom, its stability is very low. Then you can see that nickel, again, you increase that number of nickel atom into more, that is more than 30 atom, and that is called as the nickel sub nanoparticle, and its diameter, again, it is less than 1 nanometer. Again, that surface energy reduced. Again, if you increase the number of nickel atom as greater than, again, 100, so it is called as the, or near about 100, it is called as a nickel nanoparticle. And thousands of nickel nanoparticle, if they are coming together, and that is we call as nickel bulk. Nickel bulk is having the greater stability, but the surface energy or surface free energies decreases. So this is the basic fundamental why we are reducing the size to increase the surface energy, surface to volume ratio, so as to that efficiency of this particle is higher. तो हम लोग क्या कर रहे हैं कि कैन सपोज आपको लगता है कि कैन वी कन्वर्ट दिस बल्क इनटू नैनो, आंसर इज यस. So what, how we can do it? By physical method. You just cut it down, grind it, mill it, and cut into the small so you can convert into the single nickel atom. You can isolate it, and that is we called as the very small size nickel or single nickel atom, having greater surface energy, and surface to volume ratio is higher, and it is highly unstable, but you can say that energy is very high. So this is we understand by just comparing how nano is different than the bulk. uh, Next point of this Yeah, I'm moving to the next slide. 8 minutes. Sorry. Yes. Now, another is we will just understand the technology through edges. See, initially our lives, also the human being starts with the stone age. So everywhere the stone is used for building the house, getting food, hunting purpose and all that stone. Or people started living in stone, that is caves. Okay, so that's why it is called as the stone age. Then bronze started, then iron age, and in the 19th century, that is, we can say it's a chemical age. So scientists started making small molecules and materials for benefit for the human beings and all. And that is called as our 19th century. But you can see in the 1940s, there is a nuclear age. So that radioactive elements, radiochemistry. So that was becomes popular, and in the same age, the plastic has becomes an important. Becomes a part of the human life. Most of the natural things are replaced by the plastic, and it is very easy to make the plastic, and it can be useful for many applications. That is in the 20th century. In 20th century, in 1980s and all, the biotechnology. Why that biotechnology again emerged? Because of the food crisis and all. So the scientists started making that how we can use that pesticides, herbicides, then nanonutrients. That is called as the fertilizers. That's urea was also discovered, and these chemicals are used to increase the crop productions and many other things. So that is we also called as the biotechnology as this 1960, 80, and 1990. That is again we called as the material age. Materials age is nothing but there are many materials are developed. So nanotechnology also comes into the material age. Okay, and that is discovered in 1960s to 1990. So nanomaterials are discovered, but really the nanotechnology, it means that material comes into the benefit for the society or to save our environment. So we convert into the devices or product, and that's why it is called as the nanotechnology. Yes. So this is the 21st century. We are living in 21st century, and nowadays in every field that nanomaterials are coming, and that's why it is called as the nanotechnology age. Here is again just a history to understand about how this nanotechnology emerged. So I'm not repeating the previous slide, as again shows the one side, there is a discovery, and other side the year. And then there are some instrument name was also discovered, like that XRD in 1895, then Raman spectroscopy in 1928. SEM, scanning electron microscope, was developed in 1937. Tunneling electron microscope is also developed in 1938. XPS for metal analysis 1969, STM 1981, FM 1982, and many more instruments are coming because to see this material. And if these instruments are not there, we cannot believe whether it is a nano or it is a bulk material. What is the shape of that material? What is the composition of the material? What is the crystallography of this material? To understand this material, these properties, we have to know about the instrumentation. So the both sides they have given. The one side there is a discovery of the nanomaterials, and other sides there is a need of instrument to see their properties, how it is changed drastically. Then another slide, I have made it for your purpose, because here there are some BSc student, first year BSc, and few MSc students are there. So can we compare this nanoscience and nanotechnology? Many times we are confusing in understanding the nanoscience and what is the meaning of nanotechnology. So what is nanoscience? it is nothing but to understanding the fundamental properties and behavior of a material at the nanoscale. What is nanoscale? That is any one dimension in the range of 1 to 100 nanometer. That is we call as nanocell. So understand the fundamental properties. This is the fundamental property or their behavior at nanoscale. That is we call as nanoscience. What is nanotechnology? That is nothing but the application of these nanoscale material into useful devices or systems or the materials or the products for benefit of the human being or benefit of the environment, and that is we called as the technology. So materials converted into a product, that is nothing but the nanoscience to nanotechnology. To explore the phenomenon or principle that emerge with matter is manipulated at the nanoscale. It is about gaining the knowledge. And nanoscience is nothing but just now you are learning here the nanoscience. You are gaining the knowledge. You are acquiring the knowledge. You are understanding the concept. So it is nanoscience. And when you go for the application part of it, that is we call as a technology. So to design and build the functional product and solution that take advantage of the unique properties discovered through nanoscience, it's about innovation. And that is we call as innovation because you know the science and you are converting into an application. So that is the innovation. Nanoscience, nothing but a science driven. It is a multidisciplinary field involving all branches of sciences like physics, chemistry, biology, and material science. So this is the nanoscience. So here there is no subject barrier. We have to dissolve the boundaries of the subject, and then only we can do something for our nation or for the human being. So that is nanoscience. What is nanotechnology? Now here there is engineering required because to convert into a product, so some engineering field that is we called as the an engineering driven field that applies the scientific principle to solve the practical problems, because we are not expert for fabricating anything. We know science, but we'll take the help of the engineers and we can convert into a product. So this is the difference. So another, we can talk about the nanoscience, what happens to a material properties. Okay, when that material goes to the nanoscience, their optical properties, electrical properties, mechanical properties, magnetic properties. Okay, when its size reduced to nanoscale, their properties also changes. Okay, and you can see in the nanotechnology how we can use these unique nanoscale properties to create a new product or improve an existing one. And suppose some metal is showing that uh, magnetic properties. So can we make that same material into a paramagnetic, or paramagnetic into the diamagnetic, diamagnetic into the ferromagnetic? Answer is yes. You can tune these properties, whatever it is expected for your application. You can tune the properties by changing the size and their shapes. So here is an example they have given, a researcher studying how the color of gold nanoparticle changes with the size. है So that is we called as a science. And yeah, it's technology and engineer developing a nanoparticle based drug delivery system that target to the cancer cells. Suppose matlab, that material can be useful to just only target the cancer cells. Nowadays the this cancer is a very dreadful disease, and it is spreading very fast in the society. Is there any solution for today? The answer is no, because just we are increasing the shelf life of that infected patient, but we are not eradicating fully the cancer. So how we can develop such medicine or such vaccines so as to in future the no human being get affected for the cancers? So for that purpose, we can have that targeted drugs, because nowadays the drug is available. It hits to cancer cell as well as the normal cell, and that's why our immune system is get decreased and we are susceptible for many other infections. So if you design a drug in such a way that you only target the cancer cells, first is you have to locate where the cancer cells are present in early stage. And once you locate their position, then you can have that targeted drug which affect only to the cancer cell, and then there is a query is possible. So that is a challenge in front of us, and that's maybe the in future this nanotechnology will provide the solution for the same. A physicist investing a quantum effect in semiconductor nanoparticle, that is the quantum dots. So any physics people, they convert that semiconductor nowadays everywhere, electronic gadget, the semiconductors are required, like your mobile phone, laptop, and many other things. For the solar cell making, you require the semiconductors. And these semiconductors can be have for several applications. So a company manufacturing a stronger, lighter material for aircraft using the carbon nanotube. So for aircraft, the very toughest material, lightest materials are used for the aircraft making purpose. And for that, we required the toughest material like carbon nanotubes and all, or many other that is we called as the alloys are used to make the aircraft lightweight as well as the toughest one. So here we explain about the difference between the nanoscience and nanotechnology. I think you understand very clearly about these things. There are several breakthroughs during last 25 years about the nanotechnology and nanoscience. See, we will repeat it into the further more slide, these things. So, what happens for the preparing the nanomaterials and all? Here is one slide just to compare. Initially, people started from big things to convert into the smaller one, है ना? हम लोग पहाड़ों को खोद खोद के या उसके अंदर टनल्स बनाना, ये करना है, छोटे छोटे हथियार बनाना, हम लोग ने पहले बिग टू स्मॉल करने के पीछे हम लोग पड़े थे. But now this from this nanotechnology, we started from small things to bigger one. Okay, so this is the difference in the our history, that is old age, that is stone age, and now we are talking about the nanotechnology age. We are started from atom to molecules or to clusters or nanoparticles. Okay, so this is we called as bottom up approach, and previously it is the top down approach. So this is the mixture of things we understand about this nanotechnology and nanomaterials. So here is one definition. Just you can see some examples are they have given here about the gold is 0.14 nanometer, one human hair, and then all other things. Example we have seen, the methane, which is our called as the natural gas. Nowadays, it is available for the cooking purpose and all. So that one methane molecule, its size is the half a nanometer. Okay, it's very small size, but single methane molecule, it's very difficult to stable. But so the again hundreds of molecules come together in gaseous and then on. Now just I have taken here one slide, and that slide is nothing but the physicists know about this slide. Okay, because this slide is nothing but it is a scales, their symbol and हेलो, हेलो, कैन यू हियर मी?
Yes, sir.
अरे nobody has reported me when I put my this off just now, ना? हेलो, यस आरती या रोशनी शेख, आर यू हियरिंग मी?
यस
Yes,
सर।
sir.
बीच
Yes,
में
sir.
ये आवाज बंद हो गई थी ना?
अभी अभी
हाँ
हुआ।
सर, वो सिर्फ 30 सेकंड।
अरे फिर बोलने का ना। Okay, I don't know when it is happened, but it's okay. I think, can you just tell me where I was? I was at this slide.
यस सर।
Yes, okay. Uh, Now you see there is already the physicists know about the scale, okay, and here they have mentioned about this is we called as the year since what scale we are using, okay. You can see this is the positive side of the scale. That is nothing but the deca, hecto, kilo, mega, giga, tera. Nowadays we are talking about our memory devices, है ना। हम लोग अभी मोबाइल फोन खरीदते हैं तो हम बोलते हैं भाई उसका कितना गीगाबाइट्स मेमोरी कैपेसिटी होगा, है ना। सो देन वी आजकल ये टेराबाइट्स के मोबाइल्स आ गए, हार्ड डिस्क आल्सो इट कम्स टू ए टेराबाइट। सो this is we called as the tera. Tera means is nothing but 10 to the power 12. Peta means 10 to the power 15, exa 18, and so on. Our kilo is nothing but 10 to the power 3. Okay, so this is we called as the positive scale, and this side it is a positive scale. Now we just start to the looking at the negative scale. You can see in the negative scale, the decimeter, and 10 to the power minus 1, centimeter, 10 to the power minus 2, millimeter, 10 to the power minus 3, micro, 6, and then there is a nano, that is 10 to the power minus 9. And then when this nano scale is exists now here, 1960. Okay, so 1960, the nano, and then in positive side, it is called as billionth. You can see here the billion, 10 to the power minus 9, and 10 to the power minus, sorry, plus 9. Plus 9 is billionth. Okay, so this is the difference in nano. But now again, you can see minus 9 jagah or minus 12 bhi aa gaya, and that is we called as the pico. अभी टिको के पास अगेन 10 टू पावर माइनस 15 इज देयर, दैट इज कॉल्ड एज फेमटो। फिर माइनस 18 एक्टो, माइनस 21 जेप्टो। और भी इसके नीचे हो सकता है क्या? यस। So there are very, 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 very small materials are there, particles are there. We cannot see with our naked eye, but for that purpose, very, very high magnified mirror images are required, or mirrors are required to look at this. So have you understand this slide? आपको ये understand समझा क्या कि there is a positive scale and this is the negative scale. And a positive scale is nothing but the deca, hecto, kilo, meter, giga, tera. And negative scale means minus 1, that is deci, centi, milli, micro, nano. So nano, small letter n is used, that is nano. Okay. So we understand about this slide. So whenever you are talking about the scale, so this scale is already known, and that as per that materials develop, that scale is also developed and changed. So again here the repetition of size. When any material goes into the nano size, what happens? Their properties like physical properties, chemical properties, electrical properties, mechanical properties, optical properties, magnetic properties, and etc. They get drastically changed. Size change, property change. इतना आपको याद रखने का है ना। कोई मटेरियल लो, जैसे मैंने एक आपको निकल का एग्जांपल लिया था, निकल सिंगल एटम, निकल के 10 एटम आ गए साथ में तो उसका प्रॉपर्टी चेंज हो गया। निकल के 50 एटम आ गए साथ में तो उसका प्रॉपर्टी चेंज हो गया। 100 से ज्यादा आ गए, हम लोग ने उसको बोला 1000 ऑफ निकल कम टुगेदर, दैट इज वे कॉल्ड एज द बल्क निकल। property change, which property change? So all these are the properties, listed properties drastically change, and that's why this technology is having the importance. Again, here is one slide to understand how this nanomaterial is different. For example, हम लोग एक 5 cubic centimeter का एक क्यूब लेते हैं, and that 5 cubic centimeter का उन्होंने बताया कि 1 cube length is 2L, and its surface area is 24 liter square. But then you started this cutting this into the several pieces. And if you go on cutting, go on cutting, go on cutting, okay. So, and then all atom, if you spread, so it occupies the football court that is called as the our football field, okay. तो उन्होंने यहाँ पे दिया है कि अगर 5 cubic centimeter, okay, per side, उसका 1.7 centimeter per side of a material divided into 24 times, हम लोग इसको 24 टाइम्स डिवाइड करते गए, फिर इसका डिवाइड किया, ये आ गया, फिर इसको डिवाइड किया, फिर ये आ गया, उसको डिवाइड किया, ऐसे गो ऑन कटिंग 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 इनटू 24 times. And if you spread this all single layer atoms together, it covers a football field. So that is 1 nanometer. 1 nanometer, if you covered in the, it occupies the football field. So what is the meaning of this? What we understand from this? इसका मतलब हम लोग यही बोल रहे हैं कि smaller the size, larger the surface area. So that is the concept we understand here. अभी always if you say nano, so nano का मतलब ही है smaller size, larger the surface area. There are some definitions in nano, हम लोग को समझना पड़ेगा कि कौन सा है. Now cluster हम लोग किसको बोलेंगे? A collection of 50 units. Units is nothing but the atoms. The collection of 50 units we called as the clusters. इसको बोलते हैं cluster. Collide कैसे बोलेंगे? That is suppose that 1 to 1000 nanoparticles are together. It is called as the collides. Nanoparticle 1 to 100, okay, atoms are, if they are together, that is called as nanoparticle. And nanocrystal is nothing but the single crystal, 1 unit is called as the nanocrystal. Nowadays people are making nanocrystals for several applications, okay, but we are trying to make that nanoparticle, means 1 to 100 atoms are together, we call as it is a nanoparticle. So that is the few definition we must understand this one. Now here is one slide I have made it कि how this nanoparticles form, ये कैसे बनते हैं. तो उसलिए मैंने एक एग्जांपल लिया है कि suppose this is atom A and atom B. If this atom A and B combine together, what happens? It converts into a molecule, that is we called as AB. ओके, एटम तो भी इसका साइज है एंगस्ट्रॉन में, एक एटम का साइज है एंगस्ट्रॉन. एंगस्ट्रॉन मतलब 10⁻⁻10 नैनोमीटर, ओके. सो अगेन इट इज नैनो से भी ये छोटा हो गया एटम. सो इफ ए एटम इज कंबाइन और ज्वाइन विथ बी एटम्स, इट फॉर्म्स ए बी मॉलिक्यूल्स. फिर ऐसे ही हमारे मॉलिक्यूल जो है, अगर वन इट कम्स टुगेदर अबाउट 30 यूनिट्स, सो इट इज कॉल्ड एज नैनो क्लस्टर. And this 100 molecules, they come together, it is we called as the nanoparticle. ये 100 आ गए साथ में, ये 100 molecules आ गए, so it is called as nanoparticle. And thousands of these nanoparticles are joining together, it converts into a bulk. तो ये आपको समझ हो गया रहेगा कि हाउ this nanoparticles are formed and then nanoparticles converted into the bulk material. So this technique to fabricating the nanomaterial or nanoparticle is called as bottom up approach. Bottom means atom से start किया, nanoparticle तक आ गए. देन दूसरा कंसेप्ट है कि हम लोग इससे बैक भी जा सकते हैं. यस, वी कैन स्टार्ट फ्रॉम द रिवर्स साइड्स आल्सो, so that we can convert into the bulk to nano, nano to cluster, and cluster into the single crystals. So this is all about the introduction to nanotechnology. I think you understand about this introduction to nanotechnology. Is there any question would like to ask? आपको कोई question है क्या कि which thing you are not understand? So I can explain it again. So everybody understand whatever I am saying here?
Sir.
Wait,
Yes, sir.
wait. Stop recording. मैं भी stop करता हूँ यहाँ